Okay, in this video I'm going to show you how to input custom sediment data into SHSAM, into your SHSAM simulations. If you've made it this far through the tutorials, without a doubt you've found the input tab for particle size distribution in this drop menu, kind of the defaults that are in SHSAM. You've found them to be most likely inadequate if you're outside of Minnesota, or if one of these just happen to be like the soils in your area. If you're not so lucky, you need to input custom data that matches the particle size distribution on your site. So what you can do is you could enter in this custom data into this box here, but what I like to do is I like to input the data in a notepad file. And you can read this paragraph here, but basically it tells you how to set up that notepad file. Let's take a look at one. If you go into the directory where you installed SHSAM, so mine's in the C drive under Program Files 86, Bar Engineering Co. Under the SHSAM folder, you'll be able to see all the different files that SHSAM uses to work. So you'll see a file called PSD, a folder called PSD, and this contains all of the different particle size distribution data that SHSAM uses for your drop-down menu. So you can see I have 5 in there. You might have less if you just installed SHSAM. But let's take a look at one. So NJCat PSD. You can see here that there are 3 columns and there's some data. What each column represents something different. The first is the particle size, the particle diameter in microns of your distribution. The second is the percent finer, and the third is the specific gravity. So particles that are of a diameter of 1,000 microns, 100% of them are finer than that in this distribution, and the ones that are finer are 2.65 for specific gravity. Work your way down. Okay, so let's say particles that are 50 microns, of the distribution, 45% of them are smaller than 50 microns. Here, 20% are smaller than 8 microns, and only 5% are smaller than 2. So you kind of see how the distribution works. And this is what SHSAM uses to, it uses files like this to populate that drop-down menu. So if you want to input a custom one, you need to input them in this exact same format. And all you need to do is create another notepad file and fill it with data that matches that format, and SHSAM will be able to read that in your drop-down menu from then on, as long as the notepad file is in this folder. So for example, let's create one here. So I go online here and there's a particle size distribution called SilcoSil 106 or SCS 106. If I type that in Google, bring that up. So this is a manufactured sediment particle distribution, but I'm just kind of showing you how this works here. This is purely an example. So we have the micron sizes. So let's copy those and throw those into an Excel spreadsheet. Pull that out. And then percent passing. So that's percent finer as well as another way of saying that. And specific gravity, let's see if there's any documentation on that. 2.65. Okay, so we'll just fill that for all of these. Okay, so we have all the information we need. So this is a fine distribution, because you can see that 99.9% of particles are finer than 150 microns, and 73% of them are finer than 45 microns. Well, I'll go back into my folder and I'll create a new notepad file. This one will be called SCS 106 PSD. That's what I'll call it. Open that up. What you need to do is highlight these, copy them, paste. Okay. I'll save this file. And remember, do not put in the table headers into this notepad file. Leave them blank. So now I go back into SHSAM. I'll click away from that tab. Okay. Now I look in my menu and I can see SCS 106 is in my particle size distribution. So that's kind of an easy case. Now, what if you're in a situation where you do not know the particle size distribution on your site? That's a really big problem. You can't just go look up something like this online very easy. I've kind of found a good tool for estimating particle size distribution on your site. It's not the best solution out there, but it's pretty good right now. It's pretty flexible. What you should go to is go into Google. You can type in US soil maps and go to Web Soil Survey. And this is put on by the Natural Resources Conservation Service, the NRCS. So what I'll do is I'll click on Start WSS, and this program has soil maps for the entire United States. So let's say that my project was in Minnesota. What I'll do is, well, I know it's in the state, I'd fill it with Minnesota, and I know that it's kind of in the Minneapolis area. So let's say that my county is Hennepin. And you could do this for anywhere in the US, the same kind of process. Okay, so we're zooming in further here. And let's say that my site is over in this area. I'll kind of highlight this. Takes a little time to load here. Okay, so this is my site. My site is going to be on this parcel of land here. So, okay, what I'll do is I'll click on this button called Define Area of Interest by Polygon. And I'll click, and I'll kind of draw a little polygon. Say, okay, well, this is my site. And when you finish the polygon, just double click and the program will create your area of interest. This is where the program knows to populate this area with soil data. Takes a little time to load here. Okay, so our area of interest is defined. Next you go to a tab called Soil Map, and this will load the soil maps in your area of interest. So these are all the different soils. So we have all sorts of number and letter combinations here. Let's say, just for this example purposes, we really like this 1901B. That's the type of soil that we're going to have on our site, and that's the type of soil that's going to be, on the surface, and that's the stuff that's going to get washed away during a storm. So I really like 1901B. So I'll go into Soil Data Explorer and then Soil Reports. Then I'll click on resize this so you can see this better. Soil Physical Properties, Particle Size and Coarse Fragments. I'm going to view that soil report. Okay, remember 1901B, that's our size. Okay, so 1901B, there it is. Okay, we really like this Angus type soil here. So what I'll do is I'll copy everything out here. Copy that, put that in my Excel file. Let's clear out this old example. And according to the Natural Resources Conservation Service, yeah, I said that right, these are the definitions for sand, silt, and clay. So sand is 2,000 to 50 microns, silt is 50 to 2 microns, and clay is less than 2 microns. Well, in here, these are So this column here, 0 through 8, 8 through 35, 35 through 40, and 40 through 80, these are the different soil horizons. You know, soil is in layers, so these are the different horizons. So from 0 to 8 inches, the soil is 39% sand, 37% silt, and the remaining is 24% clay. So you can, there are other numbers here that mean other things. You can look at the definitions for those. These are the ones that I kind of focus on for this example. 39% sand, 37% clay, silt, and 24% clay. So let's pull this out. So these are the horizon depths: sand, silt, clay. Okay, so sand is 2,000 microns, silt is 50, and clay is 2. So we know that 39% is sand, 37% is silt, and the remaining is clay. So 100% of it is finer than sand. Everything is going to fit through a 2,000 micron sieve. And let's assume that its specific gravity is 2.65. Now, how much is smaller than 50 microns? So it looks like 37% silt and 24% clay. So we have 37 plus 24, 61. So 61% is smaller than that, 2.65. And how much is smaller than 2? That's just the remaining clay, which is 24. 2.65. So this is our particle size distribution for that soil on the site. So I'll copy this. Let's create this, and we'll call this, what was the name of that soil? It was 1901B Angus. So let's call this new text document 1901B Angus. And you don't need to put a dash PSD, it doesn't matter in the title. Okay, so just highlight these and paste these right in. Save the file and go back into your drop-down menu. Sure enough, 1901 Angus B, and you can use this in all your simulations now, and you'll get an idea of how well a BMP will capture 1901 Angus B on your site.